Of course, when you do compression of images, so you will see that histogram also gets modified. Okay, so you will see that though between the compressed version of this image PIX to this compressed version, C is a compressed version, same image. So there is not much of change that you see because it's a more or less a kind of a binary range. For example, you have a range here, you have a range here. The original picture, there are only two intensities, only this intensity and this intensity. But however, in a compressed version, some of the pixels getting modified, so they are closely values get changed because they're only an approximate, right? So these new values of the histogram that are not found in the original are seen in the compressed version of histogram. So compressed version is always an approximate version. So that is why in general medical images are never compressed. So medical image information is supposed to be not modified. So you need to do this. So I told you have to do some binning operation for a high resolution. I mean binning operation to get I mean you select a bin, for example, from intensity value AI to AI plus 1. So within this range, you collect all those number of pixels into this. So you get into what is called drawing this histogram. So large histogram, you try to do some binning operation. So calculate the bin size. For example, you have pixel values collected from 0 to 64 is one bin. You call it a h of 0. So similarly, you have other values of images, right? 0 to, so equally spaced bins, right? So depending on the size of the 14-bit image, we have two or 14 levels. So we are trying to put into 2 physics bins. So there are a range of 64 pixel values we take. So similarly, you can also think of doing it for an 8-bit image. So 2 power 8, and you want to do some, you may do it in 10 bins or, for example, or 12, 16 bins or something. So you can see how many it should be the bin size. For example, it's 2 power 4. Then, so you can see again equal to 2 power 4. So 0 to 16 is one bin. Okay, 0 to 15 or something. So 15 to 16 to another, 31 is another bin. So 32 to, the number, you can keep adding 16 values and then try to get this bin and then properly plot it, for example. So you get a histogram. So histogram of color images also can be drawn, basically because it contains RGB. So individual colors will give you, for example, individual color channels. For example, you have R channel, G channel, B channel, how they are distributed, and you have, for example, HR, HG. These are histograms. HB or the histograms. These are color components. By mixing these color components, remember, you get this image, right? So remember, this is the intensity based color. You have individual color grams, okay, individual channel color histograms, okay, intensity based color histograms. So you have both of them. So you have to find something called as a cumulative histogram. This cumulative histogram is useful. This cumulative histogram is basically addition of histograms of all values. So this is the recursive definition. Okay.